So for the following example, we want to find the three angles and three sides, or solve the triangle, given angle B is 55 degrees, side B is 10 feet, side A is 25 feet, and approximation is allowed. So if we set up our triangle, it doesn't matter what we label the angles as long as we keep the correct values with each one. Doing this, we have an angle of 55 degrees here, which means the side opposite will be B, which is 10 feet, and the side opposite angle A is 25 feet. So notice, if we check what this is, we have a side, another side, and then an angle. That's side, side, angle. That means we can solve this using the law of sines. But it is very important to note that side, side, angle is our special case for law of sines that says there could be 0, 1, or 2 solutions. So, starting off with this, we need to find our missing value. And in this case, our next missing value, that is to say. And in this case, we can't just find one of the angles because we need at least two of them to find the third. Well, sorry, we need exactly two of them to find the third. But in this case, we were given angle B and side B, and then side A, which means we can use this to find angle A. We can say sine of A over A equals sine of B over B. So plugging in our information, we get sine of A over 25 equals sine of 55 degrees over 10. And now we need to solve for angle A. We'll do so by multiplying each side of the equation by 25 over 1. Multiplying it to both sides does not change the problem. And when we do this, we can cancel out the 25 on the left, leaving us with just sine of A equals 25 times sine of 55 degrees over 10. And now finally, if we take sine inverse of each side of the equation, we'll be left with angle A equals sine inverse of the quantity of 25 times sine of 55 degrees over 10. And now if you were to plug that into your calculator, remembering to put your calculator in degree mode, you'll notice something odd happens. Your calculator is going to say something like undefined or error. And there's actually a good reasoning for this, and this is why I put that approximation was allowed on this problem. If we ignore this sine inverse and just look at this value, 25 times sine of 55 degrees over 10, then if we plug this into our calculator, while this isn't normally okay to do in an intermediate step before the final answer, it will give us a good idea of what's going on. If we plug this value in, 25 sine of 55 degrees divided by 10, we should get something like 2.0479, somewhere around there. And now, take a moment. Do you notice what's wrong with this statement? A equals sine inverse of 2.0479. Remember that sine inverse says, what angle did we plug into sine to get this 2.0479? Sine cannot be greater than 1 or less than -1. Sine can never equal 2. So this value is impossible to plug into sine inverse, meaning angle A does not exist, meaning that the triangle cannot be solved. There is no solution to this problem because the triangle ABC does not exist. So we could say no solution or triangle ABC does not exist, somewhere along those lines, just to make it known that this triangle that we drew here actually doesn't end up working out. It might end up looking something more like this, where this side doesn't actually end up connecting, so it doesn't actually form a triangle. So this is the case where side-side angle gives us 0 possible triangles for our solution.